Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Cyclopentadiene, bicyclic diene, actually the monomer with one double bond pair, undergoes HCl addition. Cyclopentadiene has two double bonds in a 5-membered ring. Addition of HCl follows Markovnikov's rule and gives the allylic chloride product A5-chlorocyclopent-1-Na, 3-chlorocyclopentene, where Cl adds to give an allylic vinylic chloride. Specifically, HCl adds across one double bond of cyclopenta 1,3 diene to give 5-chlorocyclopent-1-Na, A, via 1,4 addition, allylic addition, placing Cl at C5, the sp3 carbon, with a remaining double bond between C1 and C2. Moving on to the next step. Reaction of A with NiHCO3H2O to give B with molecular formula C5H8O. NiHCO3H2O is a mild basic aqueous condition that can hydrolyze an allylic chloride to an allylic alcohol. 5-chlorocyclopent-1-Na hydrolyzes to give cyclopent-2N1-ol B, which has the molecular formula C5H8O. This confirms B is an allylic alcohol, cyclopent-2N1-ol. Moving on to the next step. Oxidation of B with Na2Cr2O7 to give C Na2Cr2O7 is an oxidizing agent. Oxidation of the secondary allylic alcohol cyclopent-2N1-ol gives the corresponding enone, cyclopent-2N1-1, to cyclopentane. This is a cyclopentane ring with the double bond between C2 and C3 and a ketone at C1. And for the final step, the end product, C, is cyclopent-2N1-1, which matches option B, a cyclopentane with one double bond conjugated with the carbonyl. Why other options fail? A shows a cyclopentane with double bond at a different position, non-conjugated enone, not the direct oxidation product. C shows the alcohol, B, itself, not the oxidized product, C. D shows a diene or a structure with extended conjugation, which is not the product of simple alcohol oxidation. Therefore, the correct answer is B. Therefore, the correct answer is option B.